today's learning goal is I can use patterns and properties to explore multiplication and division of rational numbers. Remember, rational numbers include repeating decimals and decimals that terminate, and they also include numbers that can be made into a fraction, including integers. So 3, 4, 5, remember, can all be made into 3 over 1, 4 over 1, and 5 over 1. So let's go ahead and get started. We know what a positive and times a positive makes, and that makes another positive. We've been doing that since about 3rd grade. What we have not talked about is positive times a negative. Positive times a negative, since there's only one negative, gets us a negative. And since multiplication is commutative, meaning that it doesn't matter if you do 3 times 5 or 5 times 3, a positive times a negative is going to have the same result as a negative times a positive, which means that it's going to be a negative number. And then finally, a negative times a negative, it's like saying that I am not addicted to coffee. That would mean that I am addicted to coffee. I'm not actually addicted to coffee. I just really love it. But, so therefore, a negative times a negative is actually a positive statement.
You can't lie. So tell me, puppet, where is Shrek?
I don't know where he's not.
You're telling me you don't know where Shrek is?
It wouldn't be inaccurate to assume that I couldn't exactly not say that is or isn't almost partially incorrect.
So you do know where he is?
On the contrary.
So a negative times a negative is a positive number. So here, we say that negatives, they cancel each other out, okay, when we're talking about multiplication and division. So here, negative 2 times 6, we only have one negative, and just like our up here says, negative times a positive is negative, our answer is going to be negative 12, because 2 times 6 is 12, and a negative times a positive gets us a negative. Here, negative 20 divided by 5, here we're going to have the same rules, and remember that the rules for multiplication and division are always going to be the same because they are the same thing, just written differently. Remember that I can write negative 20 divided by 5 as negative 20 times 1, times 1/5, because that gets us, if we put negative 20 over 1, negative 20 over 5. So remember that the rules for rules for division and multiplication are going to be the same thing because they are the same thing written differently. So here, negative 20 divided by 5, that gets us negative 4 because we only have one negative, and 20 divided by 5 is 4. 5 times negative 2, again, only one negative, so we're just going to do 5 times 2, put negative in front of it, that gets us negative 10. Here we have two negatives, negative 36 divided by negative 6, and here that means that we can cancel out these negatives. So that means this is going to have the same answer as 36, positive 36, divided by 6, which gets us 6. 36 divided by 6 is 6. Here we're going to use multiple numbers here, so we have 3 times negative 3. Well, what that gets us is negative 9, because we only have one negative there. But then we're multiplying that again by negative 1. Remember that if there's no operation symbol in between these negative numbers, or inside these numbers, that means that it's multiplication. And then negative times a negative, well, we can cancel those out. Those cancel, so our answer is going to be the same thing as 9 times 1, which gets us 9. Here we have a problem in fraction form, but we have an expression in the numerator. Remember that when we have a fraction, we're always going to simplify the numerator and denominator before doing the division. So here we have negative 2 times negative 10, which means we can cancel these negatives out. We get 20 divided by negative 4. 20 divided by negative 4, that's going to give us a negative number because we only have one negative now. And so it's 20 divided by 4, which is 5, so our answer is going to be negative 5. Again, we only have one negative right here, so 40 divided by negative 8 gets us negative 5 again. Over here, we have 3 negatives. So notice how when we have an odd number of negatives, our answer is going to be negative because these two are going to cancel each other out. Right there. getting us 24 times negative 2. But we have one more negative, so therefore we're going to negative 48 is going to be our answer. Try this second row out on your own. What you should have gotten was 72 divided by negative 9 was negative 8, because there's only one negative there. Because there's only one negative in negative 8 times 7, we get negative 56. Here we get 3 times negative 8 is negative 24 times negative 2, which gets us a positive 48, because these cancel out. These negatives cancel each other out. Here we have to simplify the denominator first, which gets us negative 36. So we get negative 36 divided by negative 36. And the negatives, again, cancel each other out. And 36 divided by 36 is just 1. Here we're going to do the same thing just with fractions. The answer to the first problem, is going to be a negative number because we only have one negative number. So I'm just going to put a negative over here, knowing that our answer is going to be negative. Remember, in order to multiply fractions, we have to first make them improper. So we need to change the second fraction to an improper fraction. So we got negative 4/5 times 3 times 2 is 6 plus 1, 7 over 2. And remember that we need to multiply across, but I always like to do, and I think this is the most important thing in the world, and it's my favorite thing to do inside math. It's called cross-canceling. Remember that if a numerator and a denominator have common factors, we can simplify them before multiplying. This is going to make our lives a lot easier in the future. So here 4 and 2 have a common factor of 2, and 2 goes into 2 once, and 2 goes into 4 twice. So now we can multiply across using smaller numbers. And we get negative 14 over 5. And then we can change that to a mixed fraction, which means 5 goes into 14 twice. So we got negative 2 with a remainder of 4. Keep the denominator. Negative 2 and 4/5. Dividing fractions is a very similar process, except we have to do keep, change, flip. We also know that this question right here, 5 and 1/5 divided by negative 2 and 1/10 is going to get us a negative number because we only have one negative right here. So I'm just going to put a negative right here. Then we have to make these into improper fraction. 5 times 5 is 25 plus 1 is 26 over 5 divided by negative 2 times 10 is 20 plus 1 is 21 over 10. And then remember, with fractions, we got to do keep, change, flip. So we have 26 over 5 times negative 10 over 21. Again, we're going to do my favorite thing in the world, which is cross-canceling, because 5 can go into both 10 and 5. 5 goes into 5 once, goes into 10 twice. That's going to make our lives a lot easier because multiplying by 2 is pretty easy. So here we go. 2 times 26 is going to be 52 over 1 times 21. Oh, that's easy. 21, remember to put the negative in front, which means we need to change this into a mixed fraction. 21 goes into negative 52, or 21 goes into 52 twice with a remainder of 10, because 2 times 21 is 42, 10 over 21, and that's as simplified as it gets. Go ahead and try these 3 problems out on your own. Make sure that you are cross-canceling. Every single one of these problems that you do right here, C, D, and F, will have the ability to do some cross-canceling to make your life a lot easier. For C, what you should have found is the answer is negative, or not negative, excuse me, that should be a positive 2, holy. So positive 2, because these negatives cancel each other out, right here. So we have an answer of positive 2. Notice how we can cross cancel. 7 goes into 14 twice, and it goes into 7 once. 3 goes into 3 once, 3 goes into 3 once. So all we're really doing is a simple 2 times 1 and 1 times 1. And 2 over 1, as we know, is 2. For D, again, we could have cross-canceled in 2 ways. Right here, 2 goes into 2 twice, 2 goes into 4 twice. 2 goes into 2 once, excuse me. And then 3 goes into 3 once, and 3 goes into 3 times. And our answer is going to be negative because we only have one negative, making it negative 3 over 2, which equals negative 1.5. And finally, we have keep, change, flip with this division problem right here. And we get negative 21 over 5 times 8 over 7, because we got 4 times 5 is 20 plus 1 is 21, so we got negative 21 over 5 and times 8 over 7. Cross cancel, because 7 goes into both 21 and 7. Multiply across, 3 times 8 is negative 24, and 5 times 1 is 5, so we get negative 4 and 4/5, because we only have one negative in that problem. Here, we're going to do the same rules again, but this time we're going to use it with multiplication. So here, we know our answer is going to be negative, so I'm just going to put a negative sign right here. And what we have to do is multiply 3.2. Let me do that again. 3.2 times 4.3. And remember that we have a negative at the end, so again, I'm going to put this negative right here. Excuse me, down here, because we have to do some adding of partial products. 2 times 3, right here, we multiply the ones place, we get 6. 3 times 3, we get 9. We have 4 times 2, which is 8, and remember we're placing that in the 10th spot right here. And 3 times 4, which is 12. So I needed to put that a little bit lower. And then what we have to do is we have to add these parts. And what we get when we do that is 6. Remember, there's a 0 right here. 6. 9 plus 8 is 17. Carry the 1. We get a 3 right here and a 1. And remember, since there's 2 digits behind the decimal place, our answer should have 2 digits behind the decimal place. We're going to put our decimal right there. And that's black. You can't see that. There we go. Right there. So our final answer is going to be negative 13.76. And that makes sense because this is approximately 3, this is approximately negative 4, so negative 3 times negative 4 is negative 12, but both of these are a little bit more than that, so therefore our answer should be a little bit more than negative 12. Over here, we're going to have a positive answer because we are multiplying two negative numbers, and these negative numbers cancel each other out. And so, just to show that, sorry, there we go. Then we have 4.32 times 2.7. 4.32 times 2.7. And if we were going to estimate this, this would also be pretty close to 12. Or this, in this case, positive 12, because this is close to 3. 2.7 is close to 3. This is close to 4. And 3 times 4 is approximately 12. So let's do the multiplication out. 2 times 7 is 14. Carry the 1. 3 times 7 is 21. Plus 1 is 22. Carry the 2. 4 times 7 is 28. Plus 2 is 30. Then we do this second row. Multiplying 2 by 2 is 4. 3 times 2 is 6. 2 times 4 is 8. And again, we're adding these partial products. Remember, there's a 0 right here. So 4 plus 0 is 4. 2 plus 4 is 6. 0 plus 6 is 6. 3 plus 8 is 11. And then there are 3 digits behind the decimal right here. 1, 2, 3. So our answer is going to have a decimal right here, so that there are 3 digits behind the decimal over here. Go ahead and try these two out on your own. What you should have found is that this first one, number 3, has an answer of negative 0.372. And for number 4, you should have found that it should have an answer of 0.28. Again, remember that there are 3 digits behind the decimal in our original problem. 1, 2, 3. So our final answer should have 3 digits behind the decimal as well. 2 digits behind the decimal. So 2 digits behind the decimal as well. Here we're going to be doing division, and we're going to be doing division of decimals again. So remember, we're going to put these as an improper fraction first. Our answer is going to be negative as well, so it's 252 or 225.2 divided by negative 0.2. We're going to make both of these whole numbers so that we can multiply a little bit easier. That means we're multiplying both of these by 10 over 10. And as a result, what we get is 252 divided by negative 2. Some of us can do that in our head, but if we can't, we can use long division. Top dog in the house, 252 divided by negative 2. 2 goes into here once. And then here we get subtract 2, get 0, bring down the 5. Then we have 2 goes into 5 twice, with a remainder of 1. Bring down the next 2. Let's use a different color, orange, why not? And we find that it goes in 6 times. And then remember that this is going to be a negative answer because we're only having 1 negative in our problem. So therefore, our final answer is negative 126. Over here, our answer is going to be positive. Cancel these out. And our answer is also going to be a little bit less than 1, as we can see that 9 is greater than 7.29. So we're going to, again, multiply by 100 to get here to be a whole number. So what we have is 900 on the outside divided by 729.000. Let's just do that. And technically in this question, you didn't have to multiply by anything. You could just divide by a whole number 9, because the most important thing is that our divisor is a whole number. Doesn't matter too much about the other one, our dividend, but just for kicks and giggles, we went ahead and did that. So 900 goes into 729 0 times, and it goes into 7,200, a total of 7,290, a total of 8 times. 8 times 9 is 72. Add the 2 zeros. We subtract, we get 90. Bring down the next 0, and what we see is that it goes in 1 time. 900, subtract, and we have a remainder of 0. We are done. So our final answer is positive 81. Go ahead and try these last 2 out on your own. What you should have found is that for number 3, the answer is negative 2.3, because we only have 1 negative, so our answer is therefore going to be negative. And therefore, we multiply both the top and the bottom by 100. Do the long division out. 50 goes into 115 twice, with a remainder of 15. Drop down the next 0. 50 goes into 150 3 times, so we get 2.3. Here we're multiplying both the top and the bottom by 100 again to get 420 divided by negative 7, which, as we know, 420 divided by negative 7 is going to be negative 60, because 42 divided by 7 is 6. Add the 0 at the end, because the 0 is in the numerator. And then have a negative number because we have only 1 negative and nothing to cancel it out with.